Hello and welcome to an introductory course of measure theory and integration. In this course, we'll introduce to you Lebesgue measure. But before that, we'll start with some introductory concept. In the first lecture, we'll talk about algebra of sets. This is me, Dipjyoti Goswami. The course materials and the videos are developed by my colleague Dr. Vipul Kumar Sharma and myself. So what's an algebra? Let X be a non-empty set and script A is non-empty collection of subsets of X. A is called an algebra if script A is closed under union and complement. That means for any two element, their union is again going to be in script A, and for any element A, its A complement is again in script A. Note that for any set, it will be denoted by capital letter M. Collection of sets or subsets will be in the script form. So an algebra of a set is nothing but a collection of subsets of that set which is closed under union and complement. From the definition, it's very clear that A is closed under intersection. Try to show it by pausing the video. The proof is very simple. If any two elements are in this algebra script A, then by definition their complements are also in script A, and union of those complements again in that algebra script A. But union of those complements is nothing but complement of their intersection. And by virtue of an algebra, that means the intersection A union B is in script A, and the empty set and the full set X is in algebra script A. Again, very trivial, but try to prove it on your own. Okay, by definition script A is non-empty, so at least does the member say A, and the moment you have a member, its complement is again going to be in algebra, and their intersection and union is again in A, script A. That means empty set and X is in script A. So you can have many examples, some abstract examples. If X is non-empty, always X is non-empty. Even if we miss it, remember that X is non-empty. X is non-empty, consider this power set that consists of all subsets of X. Then it's an algebra of subsets of X. This is the largest possible algebra of subsets of X. And the smallest possible algebra is just the empty set and X. Verify both of this. There's nothing like obviously and clearly. Whenever you see these words, try to prove it on your own, and then only you have obvious or clarity. Another example, abstract example is X be a non-empty set, and let us collect all subsets of X which are finite or their complements are finite. Then this collection again represents an algebra. Pause the video right now and try to prove it. Okay, believing that you have tried, let's try to see. If A is an element, then A or A complement is finite. That means A complement or A complement is finite, and by definition A complement is in the collection. On the other hand, if A and B are two elements in the collection, then A or A complement and B or B complement are finite. If A complement or B complement is finite, then obviously their intersection is finite. We just need one of them to be finite, then the intersection is going to be finite, and thus A union B complement is finite. That means A union B belongs to the collection script A. If none of A complement or B complement is finite, that means A and B are finite, that means A union B is finite, and hence again we conclude that A union B is in script A. That means script A is an algebra. Next, we replace finite by countability. Try to prove it as an assignment for you, and this will fetch you 2 marks. Interesting part is whether we can replace countability by uncountability. So replace, consider X to be a non-empty set. can have its finite, countable, uncountable, and see whether you have a collection out there or not. And if X is a non-ambiguous set, then the collection is any subset or its complement is to be uncountable. And try to see that that collection is an algebra or not. Proposition. Let us consider an arbitrary collection of algebras of subset of X. And the proposition says that their intersection is again going to be an algebra. Proof is simple. The collection is non-empty because each of these algebra consists Phi and X. Now, if A and B are in this collection script A, then obviously by definition A and B belongs to script A alpha. That means it belongs to script A alpha for each alpha. And their union in each of these script A alpha, because A alphas, script A alphas are algebra, and again this implies that A union B is in script A. Similarly, we can show that if A belongs to script A complement is in script A. Thus, script A is an algebra. Next proposition says that given any collection script C of subsets of a set X, there is the smallest algebra script A which contains C. In other words, there is an algebra script A containing C, script C, and if script B is any algebra containing script C, then script B contains A. So this collection of subsets may not itself is an algebra. If it's an algebra, then it itself is the smallest algebra containing C. If it's not an algebra, then there is an algebra script A which is going to contain it, and this would be the smallest. In other words, if there is any other algebra beta script B containing script C, then script B would definitely contain script A. So the proof, let script F be the family of all the subsets of X that contain C. Obviously, script F is non-empty. Why? For you to verify. And then we can define script A as intersection of all these algebras that belongs to script F. And by previous proposition, script A is an algebra of subsets of X. Script A by definition contains C, since each member of script A contains C. Further, if beta is an algebra containing C, then beta is in script F. And then by construction, script A would be contained in script B. This completes the proof. Try to see that script A is unique. That means if you find under algebra which you claim to be the smallest, then it has to be the script A. So definition, let C be any collection of subsets of X. A unique smallest algebra containing script C is called the algebra generated by script C and denoted by script A of C. In the last proposition, we have seen that for any collection C, there would be a smallest algebra script A that will contain C. That is denoted by script A of C, algebra generated by C. Let us consider an example. Let X be a non-empty finite set and C is all the singleton subsets of X. The algebra generated by C is the parser. Can you prove it? Okay, very simple. Script A is the algebra generated by C, then every subset of X, which can be written as finite union of singleton sets, becomes a member of A. As such, script A is Px. In other words, we want to show that this algebra generated by C contains all possible subsets of X. Since X is finite set, remember X is finite set. Since X is a finite set, any subsets of X can be written as union of singleton sets. That means all such sets will be in script A. Hence, script A will contain any subsets of X. Now, here is a set of problems. Consider X to be some arbitrary set 1, 2, 3, 4, 5, and you can do all possible algebras of X and whatever you have learned in definitions, examples, abstract examples, propositions. Replace X and try to work it out. Thank you.